If you observe here, the structure visually shows like a cube. When I cut a cube, we get a rectangle. There may be different cuts may be there, right? Suppose if I have 100 locations, now if I say the number of sales of products on various timelines at each location can be considered as one two-dimensional structure. So if I put all these structures one after the other in the form of slices, we get a three-dimensional structure. So this diagram shows a front side view of the cube, which imitates the behavior or the values shown on the right hand side in the form of a three-dimensional structure. So if you observe here, what are the advantages we get from this? What are the disadvantages we get from this? So if you observe here, by seeing this, all the sales about the combination of product ID and location IDs at a particular location 1, by seeing this picture, straight away I can make analysis very quickly. One thing I can say, why sales are very less at time 2 for product 1 and product 3 at time 1. Sales for product 2, I2 or 12 is very high, whereas sales for other things are average. So like this, we get some quicker analysis. So it is easy to think the way the managers think. In the same way, we are arranging the data items so that managers can take quicker decision. Suppose if you imagine if you have a lot of items here, I gave an example only in order to show the picture. I have taken only 3 items. Suppose you have 1,000 items, 10,000 locations with 100,000 products. Then doing analysis on the right-hand side representation, which is called array-based representation, is very time-consuming. Unless we query and get the data, I can't get any decision or outcome. I cannot take any decision quickly. But whereas here, by seeing this picture, I can easily, this three-dimensional structure, I can take decisions very fast. That's why it's called a multi-dimensional model representation, which we call this as a data cube. Left side structure is called data cube. Data in a database or data warehouse is arranged in the form of a visual structure called data cube. Okay. Now, so what is the suitability? Multi-dimensional model is suitable for large corporate data warehouses and data marts. In the sense that for large data warehouses and data repositories or subject-specific data marts or dependent data marts or warehouses, are from the warehouse I can derive some high performance structure which we call as data marts. So in that situation, this multidimensional modeling is highly suitable. And of course, I can generalize this to not only 3 dimensions, I can generalize to n dimensions also. But more than 3, I can't show visually, which we can think in an abstract sense. So a hypercube, which we call a hypercube. A hypercube of n dimension is represented as a hypercube of n-1 dimensional planes. A hypercube of 3 dimension is represented in terms of 2-dimensional squares. A 2-dimensional representation is represented in terms of 1-dimensional square or row. So like this, we can generalize the hypercube, but visually I can't play. I can't play when it is more than 3. When it is more than 3, you have to use some dashboard and some filters, and then we have to map the dimensions using the software. Therefore, MOLAPs, MOLAP, actually there are different kinds of analytical processing systems are there. Multi-dimensional online analytical processing system is one kind of system called MOLAP. It uses a multi-dimensional array, whereas tabular representation is a column-based representation. So array representations, arrays are much faster than the tabular representation. Each tabular representation, you need a lookup operation to retrieve the data first. Unless we scan the entire table, I can't get it. But whereas in array representation, straight away I can pick up. That's why MOLAP systems are much faster than the tabular representation. Then this is another example. See, yesterday I gave some demonstration how to use union all, etc. Right? Now, if you observe here, this is a simple data cube consisting of 3 dimensions: product, date, and cities. Right? Suppose as a manager, I can ask any question at any time based on my requirement, my need. But in normal databases, unless we predefine and then prepare the query, I can't run the query. I can't get the answer. But whereas manager's time is very crucial. We have to provide everything in one shot so that manager can play with the cube. Playing with the cube means during olden days, during our normally kids play with the cube. They can rotate the vertical, horizontal, or mixed, or they can cut horizontally, or they can tuck vertically, etc. So in the same logic, if you apply here, for example, this is a total sales for a product T, this row, product, this slice, this is the last plane. Total sales for the TV product on every quarter in a city, Hyderabad. And similarly, if I take the front side view, the front side view is sum of sales of all products for each quarter. This is the sum of sales. On the top of this is the sum of the sales of all 3 products in quarter 1, quarter 2, quarter 3, quarter 4. Whereas here, sum of total sales for each particular product, in every year, in every quarter, total. This total is for this. Similarly, if you take this one, this is sum of sales of all products, of all quarters, at all cities. Right? So if you observe here, we have different kinds of computations. But in database, we have only product ID, location, that means city, and quarterly sales, or you may be having unit sales. But I am pre-computing everything as per the requirements of the managers. Then manager, once everything is ready, manager need not query everything. Manager can only manipulate the cube. Like our database operations, cubes can be manipulated. The manager can only manipulate the cube by doing some operations on the cube. Those operations are called OLAP operations. OLAP, Online Analytical Processing Operations. Right? So then how do we represent this? So what is the structure? How do we build structure? Suppose yesterday in MS SQL server, there is no structure to build a cube. But can we build a structure? Yes, the answer is yes. We can build a structure. If you observe here, we have 8 combinations of values, 8 combinations of aggregations. This is grand sales. All means what? All products over all quarters for all cities. This is all. Whereas this is for each product over all quarters total. Whereas this for each quarter on all products sums. And you take this and this in a particular quarter on a particular product sum. If I take this and this on a particular quarter, on a particular city sum. So if you observe this, you have several combinations of computations. These computations are called sums, aggregations. So these aggregations can be, if I compute all these aggregations together and build a structure like this, whether visually you see or not, at the back end, if the data is available with all these combinations of computations, then I can dig any visualization tool and I can show the pictorially the structure of the data, so that managers can query whatever the answer they want, they can get it from this easily. He can't expect to get any answer other than these combinations as far as product sales and cities are concerned. So that's why this is known as OLAP structure called data cube. Now, so if you observe here, this is how representation is made. Individual cell, a particular cell tells you the sales of a particular product on a particular quarter in a particular city or country. This is one combination. And this combination is the total sales for all products over all dates for all countries. And between these two extremes, you have different kinds of computations. One is product date computation. Then another is sales for each product, sales for each date, sales for each country. Another is sales on each product on each date, sales on product country date, sales on date country. So if you observe here, these are all 8 different combinations are there. That means if I have a 3-dimensional structure, I have to compute 2 to the power of 3 combinations of aggregations. That's why 8 points are here. All these 8 points are nicely visualized using a picture. Then we get this picture like this. But inherent mathematics, what is the inherent mathematics involved in this? Can anybody give an answer for this? Let us take some questions here. So is multidimensional model and data cube, representation, aggregations, is clear? Any questions on this point? Yes?
Sir,
Yeah.
if we have more than 3 types of data, we can use the cube model only.
More
Different
than
types.
3 dimensions data, you cannot visually represent, but you can compute. See, in a 3-dimensional cube, we have 3 dimensions only, right? In 4 dimension, what is the visualization?
But
is there any
in
visualization?
No, not for visualization, sir, for computation only. But
In
backend
backend we can compute. I will tell you, in backend we can compute the cube. Any number of dimensions we can compute it the backend. But as far as visualization is concerned, you have to dig and then generalize some dimensions. Then only you can show everything. Because if you take 3 dimensions, we have x-axis, y-axis, z-axis. So a cube, what is a cube? Cube is a collection of 2-dimensional squares. Is it not? And a cube is given, this is the one layer, this is another layer. Take a bread slice cube, bread slice. If you go to market, you may buy bread. What do you have? You will have a bread slice like this, because more slices are there. So each slice can be considered as a square. And you pick up a slice, it is considered as a square, and then I can see the top of the square. So if you have different slices, if you arrange the structure, then it is called a cube. So in the sense that cube is a generalization of collection of squares, two-dimensional squares. Then how square is done? Square is a collection of either one-dimensional row or column. Is it not? You are putting rows, columns like this, either this way or this way. You can take either this way or you can take either this way. Then what is a quadruple? 4 dimensions. If you do, what is the structure of 4 dimension visually? It is no visualization. We can always say that it's a collection of cubes. A 4-dimensional structure is a representation of collection of cubes. If I take each dimension, cut it, I will get 1 cube. If I cut a 3 cube, I'll get a square. If I cut a square, I'll get a row or column. So like this, an n-dimensional cube is represented as a collection of n-dimensional, n-1 dimensional hyperplanes. A 3-dimensional plane is represented as a 2-dimensional planes. A 2-dimensional plane is represented as a 1-dimensional plane. So like this, you have to generate. But if you want to compute, you can always compute. But visually, I cannot represent like a data cube in the 3-dimensional cube. But whatever the operations and computations you want to get it, that you can always compute. That I will show you now. Any other question? Any question?
No, sir. Thank you.
Shall I continue?
Sir, sir.
Yeah, okay. Now I'm continuing. So now, if you observe here, yesterday I gave, right? In SQL, how do you compute total sales? Yesterday we gave, right? Select sum sales. Sales is a column. Select sum sales from sales data, say. Then you get this value. You get this value. Grand sales. That means whatever data you have on product, date, country, it will take all the sales values of every combination of product, date, country. Total sum is calculated. So this is one point. Now, from the same sales data, can I get total sales for each product? Yes, we can write select product, comma, product ID, comma, sum sales from sales data, group by product. Whatever the products, distinct products are there, all sales related to that product are grouped together, and then sum of the sales of those products values are computed. So that is this point. Similarly, for each date, there can be several sales happen on each day at different locations. So all the data you are grouping here. So group by date. Similarly, country size, country-wise sales. So by changing group by with product, group by with date, group by with the country, you get these dots. Then I can combine what are the sales date-wise for each product. There can be several products. First, I am grouping with product. Within the group of the product, whatever the sales are happen on different dates, for each date, total sales of that product. So that is product date combination. Similarly, product country combination. Similarly, date country combination. Similarly, this cell gives what are the sales in a particular country on a particular day for a particular product. This is a row and one single value. Now, if you combine all these results into a single table, it is called a cube. Yesterday, we have used union to combine. So here we are getting a 1-column result. Here we are getting 2-column result. Here we are getting 3-column results. Here we are getting 4-column result. So how do you combine all these things? 1-column result, 2-column result, 3-column result, 4-column result. So if you write a query in SQL, you can combine everything into a single table. Once the results are available, then every time I need not compute all these things on the fly on the large data. I can always take the values from the structure, from a database structure. So that is called data cube. So therefore, we can simulate a data cube using SQL. Using SQL. So to do that, what you have to do? You have to use group by class, and then you have to use union all. Then you have to use dummy column, because here we have 4 columns are there. Here 4 columns are there. Here 1 column is there. I cannot combine union. In order to make union, you should have same number of columns, same type, same order, etc. So in order you make it same, what you do is you add a null column. Yesterday we added, right? Null, comma, null, comma, null, all. Whereas here I write product, comma, null, then sales will come. Null, date, null, null, country. Like that, I will make it union compatible, and then I will combine everything into a single table. So this is called a simulation of a data cube using SQL queries. Right? So in a way, by writing 8 queries and using union all, we get a complete results of the structure values. So whatever then those values visually you are representing here, right? Those values you are representing here. So that is called data cube. So these are known as cuboids. 1 0-dimensional cuboid, 3-dimensional cuboid, 2-dimensional cuboid, 1-dimensional cuboid. If 1 dimension is there in the group by class, it is called 1-dimensional cuboid. If no dimension is there in group by class, it is called 0 dimension. If all dimensions are there, it is called 3-dimension. So all these values from bottom to top, this one, all these things can be computed provided if you have a data of this correctly. If complete data is available here, all these things I can pre-compute by running queries and then store in a table. So this is called a data cube implementation. Right, so this is what the entire things square wise. In order to give a video lecture, I have used all these things. So I will provide my video lecture also. A long time back, I prepared a video lecture for this. So I will share it to you in the Google Drive later. So this is my cubes. Okay. Now, if I add one more dimension, so earlier, madam has asked, partly has asked a question. Can you do for everything? Yes, you can do for everything. So this is a 4-dimensional cuboid. 2 to the power of 4. That means 16 times 16 cuboids are there. 1 cube, this is 0 dimension, this is 4 dimension, these are 3 dimensions, 2 dimensions, 1 dimension. All possible combinations of cuboids we are computing. So if you do this, if you see these things, these cuboids, there is a concept of lattice. In mathematics, those who are having strong background of statistics background, science background, they can understand lattice. A lattice is a partial adder set with the greatest lower bound and least upper bound. So whatever the computation you do in these things, all those computations of these circles, dots, are always more than the particular cell value over the combinations of these, or at the most maybe equal. So this is called greatest lower bound. Whatever you compute, it is always more than that. Similarly, whatever you compute in these things, the value is always less than the grand value, which is all. So a greatest lower bound with least upper bound and a partial adder. There is a ordering exists. So from time location data, I can compute the grand sales over time. Similarly, from item location data, I can compute a grand sales per item and location. So like this, from lower dimensions, I can get the higher dimensional value summations very quickly. That's why it is termed as a lattice of cuboids. A data cube is nothing but a lattice of cuboids. It is represented in terms of lattice of cuboids concept. Clear? Any questions? Hello, any questions? Is my connection is okay?
No, sir.
Yes, sir.
Yes, sir.
So any questions now?
No questions, sir.
See, if there are no questions, there are two things I can assess. You are all non-computer science faculty. If you are not asking questions, means either you are not serious in listening or you might have understood completely. Which one I assume? So what I did, as I said, I have prepared my video lecture. I will share the video in a Google Drive in Moodle. But I gave a presentation up to these slides. Then in 2000, this was happened in 2004. Sometime in the year 2004, I gave the presentation, I shared the slides, and then I took the questionnaires from students, from 128 students. Then again, those questionnaire data I have taken and then formulated the questions. Whether you have questions or not, I will show you the questions. What are the questions NIT Warangal computer science students asked me in the class in the form of questionnaire? Right? Sometimes students may not have courage to ask questions, but they will write the feedback very quickly. So based on the feedback, I have added. So this was a question madam has already asked. What is hypercube? How is it be viewed? So hypercube is a basic structure used to understand multidimensional software. You can think in similar lines of spreadsheets and databases. This I told already yesterday. Spreadsheets are nothing but worksheets, right? It uses worksheets. Whereas databases uses tables. Hypercubes are used to understand multidimensional views. Different views of the same data. Base data is same. Different views of the same data is clearly can be categorized and then understand very easily using the concept of hypercubes. For example, consider two-dimensional report. In Excel sheet, there is a crosstab report, two-dimensional crosstab report. So if I can use a grid, drag and drop, and then I can prepare the report. Where rows and columns are nothing but headings. And intersection of row and column is nothing but a measure. So that is a grid structure. Grid structure is used already in Excel sheet. So how is it is viewed? Viewing is done, as I said, suppose you have a video recorder, say. Imagine there is a control panel on a stereo sound system. Each slider control one aspect of the sound. We have different types, right? Balance, volume, bass, treble. But there are all 4 different views. But all those things are simulated this was not modeled, simulated in the form of a control panel. So what is going to happen if we add more and more dimensions for our 3-dimensional structure, like payment method, gift coupons, etc.? The grid is going to expand. So the grid is going to expand in the form of different planes. So that's why these are called as hypercubes. So viewing is always done. Representation, there is a software called Tableau. In a Tableau, I can do all these things viewing very easily. But when you see the mathematical concept is this one. This is a great mathematical concept used. Based on this simple logic, the entire business is driven by the software people very easily by doing some structures and dashboards, computations, backend software, etc. So this was happened in 2000s. If you know the ABCDs of Cognos, IBM multidimensional software, Informatica, you are highly paid professionals. right? Then, and also there is a power cube, Informatica power cube called, which we call as a transformers. So again, see, there are different kinds of parameters are there, but all those parameters are taken into consideration in building the business dimensions or business perspectives. Then how do we represent? Cube represents data as cells in an array. Relational table only represents multi-dimensional data in the column dimensions. So representation. So this is already explained earlier. So all these things, again, can you explain lattice with example? Already explained this. Then, so how do we view relational DBMS as multi-dimensional databases? In relational databases, data is viewed as columns and tables, whereas in multi-dimensional database viewed as an array. See, the left-hand side is easy to understand than the right-hand side, because this is a dashboard. The column values becomes row headings, and the sales value becomes a measure. Then you can also perform complex query analysis. So complex query analysis you can do, and you can do some hierarchy and then build the dimensions, right? So these are all possible in the case of OLAP system. We can't do this in database systems. So what are the operations? The operations are slicing, dicing, drill down, drill up or roll up, and pivot. Slicing means what? You have to cut it horizontally. Dicing is vertically. Sometimes you can mix both horizontal and vertical also. So if you want to do bread bhuja, bread will cut both horizontal and vertical also. Then small cubes you will get. So slicing and dicing together. Drill down means going from higher level summary to lower level summary. Highest sales to quarter, daily, hourly, or minute sales of a particular category of product. It's a drill down. Roll up is reverse, from lower level sales, lower level values to higher level values. Pivot means rotation, swapping the dimensions. Data values are same, but I can reorganize my vertical axis, horizontal axis, three-dimensional. I can rotate by interchanging the dimensions. So which is called pivoting. So on any OLAP data cube, these are the operations on data cube. On data cube, we can perform these basic operators, but in addition to that, we have other high-level operations called drill across, drill through, etc. But these are the things you should understand initially first, right? So other operations already I mentioned here: pivot, rotate, drill down, reverse, roll up, other operations. So the summary of the operations are also given here. You can go through that, and aggregates, example, self-explanatory in SQL queries, how it is given, also shown here, how it computes, and then what is the query. Then similarly, slicing, dicing, aggregations. See, group by class, if you observe here, the aggregations are this is group by date. Date means there are 4 columns are there, 4 rows. All these sums are calculated and shown here. Whereas here, these 2 sum are calculated. So when you run the query, a larger table data is summarized into a smaller table data. So this is called a roll up, lower summary to higher summary. If you reverse it, it is roll down. So data cube, see, if you observe, we have a time, daily sales. If you put for a year or for 10 years, your cube will be very large cube. If more locations and more cities are added, more products are added, bigger cube will come, right? So this can be hierarchically organized, and then measures can be computed and then recorded in the form of sales. So these are the different operations. So this is a simple example to understand roll up and roll down. So roll up means going this side, drill down means going this side, reverse. So typical MOLAP cube, suppose if I take a 2-dimensional structure, and if I want to organize this into a multi-dimensional view, it will be like this. So from this, you can say that there are no sales for S1, sales S1 item at store S1, P1, no sales are there. That's why 0. So this is how we should see. So this is another view, layered view, day 1, day 2, etc. Then these are all different kinds of representations we can do in the case of roll up and drill down and drill up, etc. Right? So this is another operation on roll up on a cube. See, this is our whatever the lattice cuboid is explained. All those computations are done here in this presentation. This is grand sum, and where these are the lower level sums, and these are the middle level sums. So sum of our sales, whereas this is sum of our product and sales combination. These are product days and sales combination. This is for a particular day. So this is for overall days, for all products and all locations. So all these things are possible to do using these computations. So these computations, as I said, star comma star is nothing but null comma null. Additional columns are added here and then computations are made. So whenever value is not there, we put null. So this is another example for extended cube, right? So hierarchically also you can organize and then store these computations very easily. So these are the different kinds of questions posed by students. Then I have refined my presentation. So maybe today I will store, I will upload all these videos. So I think you are all going through the Moodle login. How many are actively using Moodle? Today I gave all my presentations, schedule and assignments. I uploaded in the Moodle site in the course DSC, Data Science for Engineers. All of you please go through that. Whatever the assignments I gave, all those things formally I have written and then gave 1 week deadline for one assignment, maybe 10 days deadline for another assignment like that. So within the deadline, please upload the assignments in a single PDF. And also whatever the material I used, that is also shared. Now what I do is I will upload my video lecture of this entire OLAP, data warehousing, whatever I have, original lectures, those video lectures also I will upload into the Moodle site. Those who are interested, they can go into the details about that video. Okay? Clear? So today I talked about OLAP and operations of OLAP. Tomorrow we will discuss what are the different types of OLAPs. And then we will close this chapter number 10, data warehousing, OLAP, etc. Then I will talk about multimedia in-memory analytics later. But before going through, who has presented yesterday the W3 schools? What is her name?
Vani madam, Vani.
Vani madam, has she attended today? Vani is present today?
Yes, sir.
Yeah, Vani, you can send in the group your presentation slides. That also I will upload in the Moodle set so that everybody can take the material very easily. Okay, kindly share it in a WhatsApp group. Then I will add one lecture in that point, and then I will add it. Okay, it's clear?
Yes, sir. Yes.
Okay. Okay then. Thank you all. Thank you.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.